All right, let's try that again. Here it says Caitlin has $8.55 in quarters and dimes. The number of quarters is three more than twice the number of dimes. How many dimes and how many quarters does Caitlin have? So the quantities involved here are both numbers of coins and the dollar amounts for each type of coin. And so I've started off picking out variables, Q for number of quarters, D for number of dimes. So our first equation is going to be about the dollar amount. That $8.55 comes from two sources. The quarters are worth 25 cents for each one. So we'll have 25 cents times the number of quarters. And then we'll add on the money for the dimes. So that will be 0.10 times D for the number of dimes. So this will give us the equation for the money. And then the number of quarters, that's Q, is 3 more than, so 3 plus, twice the number of dimes. So Q will be 3 plus 2D. All right, so this is our system of two equations. Again, make sure that you understand how we got this system from the wording, and then we'll go into solving it. So taking a look at that first equation, I can see that the all of the numbers involved are divisible by 0.05. So to make this simpler to solve, we're going to divide throughout by 0.05. And if you don't want to, you don't have to, but it's going to be easier if we do that. 855 divided by 0.05 will be 171. And then that will be 5Q plus 2D. And then we have Q is 3 plus 2D. All right, so that took care of eliminating decimals for us and making the numbers significantly easier to work with. All right, so now this equation is suitable for us to use substitution. So I'm going to replace the Q by 3 plus 2D in the first equation. So we'll have 171 is 5Q plus 2D. But wait, that Q is 3 plus 2D. All right, now our equation just involves D. And so let's continue solving that. We'll distribute to remove parentheses. That'll be 15 plus 10D on the right side, plus the 2D we already had. Taking 15 from 171, that's 156. And then on the right side, we should have 12D. And then 156 divided by 12, that's D. That better come out even, right? Because we're talking about a number of coins. So it looks like 13. Okay, so we've got 13 dimes. We're going to back substitute to find out how many quarters we have. So Q should be 3 plus 2D. And that's 26 plus 3 or 29. So 29 quarters. And then it was 13 dimes. Okay, and then just for fun, let's double check and make sure that that works out. Here, of course, the number of quarters, that's 29, is 3 more than 2 times 13. Let's check the dollar amount. 13 dimes works out to be $1.30. And then 29 quarters works out to be $7.25. And then if you add that together, you are going to get the 855 that we started with. So that checks out. Sometimes it's a good idea to check these things and make sure that they work. Okay, that takes us to the end of our coin problem. So let's see what we've got next. This one is going to be a nut mixture problem, and those are always fun. So sometimes it's nuts, sometimes it's candies, sometimes it's nuts and candy. It just depends. All right, so here it says D wants to make 5 pounds of a nut mix using peanuts and cashews. Her budget requires that the mixture to cost her $6 a pound. Peanuts cost $4 a pound. Cashews cost $9 a pound. We want to know how many pounds of each type of nut she should use. So first of all, we want to think about this and make sure that it makes sense. Peanuts are $4 a pound, right? And cashews are 6. If she's going to make this mixture cashews are $9 a pound. The mix is 6. If she wants to try to sell, let's say she's selling this nut mixture for $6 a pound, and it's full of cashews at $9 a pound, that wouldn't be very smart on Dee's part, right? Because she's buying cashews for $9 and selling them for 6. Similarly, if she's trying to make it all peanuts at $4 a pound, not many people are going to buy something that's a lot of cheap peanuts and pay $6 a pound for it. So it's got to be a mix of the cheaper peanuts and the more expensive cashews. Okay, the two quantities that we have involved here are the weights in pounds for the two types of these nuts, and then the dollar amounts for the nuts. Okay, so that will give the two equations. So our variables are the numbers of pounds of each type of nut we have. So let's go with P for pounds of peanuts. And then we'll go with C for pounds of cashews. Okay, all right. So she wants to make 5 pounds of a nut mix using peanuts and cashews. So that part tells us that P plus C has to be 5. Right? The number of pounds of peanuts plus the number of pounds of cashews has to be 5. The equation about the money is she's spending $4 a pound on the peanuts. So the total dollars that she'll spend on peanuts is then 4p. Similarly, she's spending $9 a pound on cashews, and each pound is $9, and she's buying C pounds, so it's 9C for the amount of money she spends on cashews. So her mix is going to cost $6 a pound, and she's making 5 pounds, so that's 6 times 5 or 30. I realize 6 times 5 is 30, but this time I just felt like leaving it unmultiplied so that you could see that it was a dollar amount per pound times pounds, dollar amount per pound times pounds, and then dollar amount per pound times pounds. The structure is kind of uniform all the way across. Okay, so this will be our equation then, or our system of equations. So we want to solve for both P and C. I'm going to use elimination this time. We'll multiply the first equation by -4. And so that will give us -4p minus 4c is -20. And then 4p plus 9c is equal to 30. Now when we add together the two equations, the p's will go away, and we'll have 5c is equal to 10, so that c is 2. So that's pretty straightforward. And then if we know that c is 2, we can back substitute to find out the value for p. It's got to be 3, right? Okay, so if we use 2 pounds of cashews and 3 pounds of peanuts, that will give us a 5-pound mixture. Let's go ahead and make sure that the money works out. Cashews are $9 a pound. If we got 2 pounds, we'd be spending $18 on cashews. And then peanuts are $4 a pound. And so if we get 3 pounds of peanuts at $4 a pound, that will be $12. Altogether, that's the $30. If we're spending $30 on 5 pounds of nuts, that averages out to $5 a pound. So we've done it. So let me write out our answer nicely. Pounds peanuts and 2 pounds cashews. Okay, so there's that. Okay, next one. This one has got kind of a chemistry look to it, but it's really not as bad as it might seem at first. Here the story is that Taylor needs 150 milliliters of a 30% sulfuric acid solution for a lab experiment, but only has access to 25% and 50% solution. We want to know how much of each of the two 25 and 50 solutions should be mixed to make a 30% solution. So if it bothers you about the acid, if you're thinking, okay, well, I never took chemistry or whatever, it doesn't matter. You can make this like fruit juice or something, okay? That part is not really relevant to the question. The quantities that we have are the total volumes of each solution and the amount of acid, fruit juice if you like, within each component ingredient. So for this one, I'm going to let X be the number of milliliters of the 25% solution. So it's like 25% acid and the rest is water or something, or it's fruit juice and water, whatever. Y will be the number of milliliters of the 50% solution. Okay, so the Taylor wants to make this 150 milliliters of a 30% solution. So if she used 25% solution, all of it, then it's clearly not going to make 30%. We need to use some 50 to bring up the concentration in the direction of 30. And on the other hand, if we made it all 50%, then that's too strong, right? We only want it to be 30% solution. So we've got to mix some of the weaker one and some of the stronger one to make it just right. Okay, so the first equation is going to be about the total amount of volume, and that's the 150 milliliters that we're trying to make. So x plus y has to be 150. So we have these two things that we're combining. The first one, we have a 25% solution. We have x total milliliters of it, out of which a quarter, or 25%, is the actual acid, and the rest is water or whatever. For the other one, we have a 50% solution, and so it's like half acid and the other half is like water or something, and we have y milliliters of it. So we're combining these two things, the x plus y, and that needs to make the 150 total milliliters of liquid. But then we have this acid contained within each of these solutions, and so we need to have an equation about that. So the first one, we know that 25% of the x milliliters of 25% solution, that will go into our end product. And then additionally, we'll have 50%, so 0.50 y, that's 50% of the 50% solution. That has to make our end product, which is 150 milliliters total, but it's not all acid, right? It's only supposed to be 30% solution. So I can tell you right now that usually people find this type of mixture problem the hardest because it's just percents and percents. And when it's coins, it's like two different things. It's money versus coins, which is like two different things. This is just percents and percents, and usually people find that a little harder. So be careful. Our first equation is about the total fluid volume, how many milliliters there are in the two solutions. The second equation is about how much acid is inside those two things that we are combining. So there's our two equations. The second equation, I think we can go ahead and simplify that a little bit. So let me recopy that. X plus y is 150. And then let me do this in two steps. So 30% of 150 is 45, right? Okay, so there's our equations. And so how to best do this. So we want to eliminate a variable. And while you could move the decimal point over to remove the decimals, I don't think that that's really necessary. And plus, that's going to make my 45 into 4,500. That's really bigger than I feel like dealing with. Instead, let's notice that 0.5 is half of 1. So we're going to multiply by -2, and that will help us eliminate y's. You'll up top, we have x plus y is 150. Down below, -2 times 0.25 is -0.5. And then 0.5 times -2 is -1. So that takes care of that. And then 45 times -2 is -90. All right, so there's that. That takes care of eliminating or making it so we can eliminate our y's. X minus a half of x will leave us a half of x. The y's are gone. 150 minus 90 is 60. So we know that half of x is 60. That means x has to be 100. Okay, we know that we're making 150 total milliliters of solution. That's x is the 120, so that means that the y has to be 30. Okay, the x was the 25% solution, so we'll be using 25% solution. Write that in the other order. That will be nicer. So we'll have 120 milliliters of 25% solution. That was our x. and then 30 milliliters of the 50% solution. Okay, and that takes us to the end of that. Our next mixture problem that we'll look at is an investment problem. This one involves using simple interest. As a reminder, the formula for simple interest is I is equal to P times R times T. I is the dollar amount of interest that's earned. T is the principal or amount borrowed or lent or invested. R is the interest rate turned into a decimal, and T is the time. For this problem, we're looking at how much interest this guy is going to earn per year. And so if it's on a per year basis, so for the purposes of this problem, our T is going to equal 1. It's in 1 year. So we'll be dealing with a simpler formula. I is equal to P times principal times rate. Okay, so here's the story. Sam has $50,000 to invest and hopes to earn 6.2% interest per year. He'll put some money into a stock fund that pays 7% interest per year, and the rest into a CD that pays 2% per year. We want to know how much Sam should put into each type of investment. So variables, let's go with X is the dollars in the stock fund. And Y will be the amount of dollars in the CD. Of course, a natural question would be, why wouldn't he just put all of it into the 7% stock fund? Well, let's say that there's a risk of maybe losing money if he puts it into the stock fund. And so he wants to balance that risk by putting some money into the CD. Of course, it would probably be safest to put all the money into the CD, but the CD only pays 2% per year. So he's trying to increase the amount of interest he earns by taking on a little risk, putting some of the money into the stock fund. That's why it's a mix of two different things instead of just all stock fund or all CD. Okay, so in this case, our equation is all money. Our equations are both about money, not like coins and dollars or two different kinds of nuts or something, but it's all money. But there's the total amount of money that's invested and the interest. So the two equations are the total balances in the two accounts and the amounts of interest. So the principal amounts first. That 50,000 is split up into two parts. It's going to be X in the stock fund and Y into the CD. So X plus Y has to be 5,000, or rather 50,000. Sorry, I lost a zero. So X plus Y together has to make 50,000. That's just referring to the money that he's investing. Then the next piece has to do with the interest. So interest is going to be principal times rate. Remember, we're doing this per year, so it's T is 1 for this. So the stock fund pays 7% interest per year. So the amount of money earned in the stock fund is going to be 0.07. That's the rate times the principal, which is X. Here I'm really doing RP instead of PR, just because it's customary to put the numbers in front. And if I did X times 0.07, none of us would like it. So forget that. We'll have 0.07X instead of X times 0.07. So rate times principal. For the CD, it's 2% a year, so it's going to be 0.02 times Y. And then that's going to tell us the total amount of interest. So Sam wants to earn 6.2% interest. So as a decimal, that's 0.062. And he's earning 0.062 on that 50,000. Okay, so you'll notice that we have a similar structure to problems we did earlier. Notice that we have a product, 0.07 times X, plus another product, 0.02 times Y, and that's equal to another product. So the structure that you're seeing in the mixture problems kind of comes up over and over again. Okay, so there's that. Let's see if we can simplify some of these equations a little bit. First one I can't do anything with. That will be X plus Y is 50,000. And then for the second one, I'm just going to multiply that 0.062 by the 50,000. That's all we'll do in this step. So the 6.2% of the 50,000 works out to be 3,100. Okay. All right, so there's that. So now I want to think about how we can eliminate the decimals. I think it'll be easier on us if we go ahead and do that. So let's go ahead and move the decimal point over 2 places, or equivalently multiply by 100, to eliminate that decimal. Our first equation stays the same. And then our second one will have 7x plus 2y is equal to 3100, plus I need 2 more zeros now. So now I'm going to want to eliminate y's. Okay, it's just going to be easier than doing x's. So let's multiply that first equation by -2. So we'll have minus 2x minus 2y is equal to minus 100,000. Okay, our second equation is staying the same. That was 310,000, isn't it? Okay, so now we can combine our two equations. That will give us 5x. There are no y's, and then 210,000. And that looks good. And then to get our x, we'll divide the 210,000 by 5. And I think that's 42. But let's check. Yep, that's 42. Okay. Okay. All right. So let's take a look at that as a whole. All right, so that's looking pretty good. When I did the division, I just typed 210 by 5 into my calculator. I neglected the zero. So, of course, that's 42,000, not just 42. That's why I paused for a second. $42 is going to be too little in the stock fund. Okay, so X was the dollar amount in the stock fund. So we're going to have 42,000 in the stock fund. And then the total amount of the investment was 50,000. So that's a difference of 8,000. And so we'll see 8,000 into the CD. So again, most of it is into the stock fund, which makes sense because the stock fund pays 7% per year. Putting part of it into the CD just lowers the overall earning in to be 6.2%. So it doesn't lower it by very much because most of the money is still in the stock fund. Okay, so that's that one. Our last example involves cost and revenue functions. So, so the story here, suppose a company sells X units of a product. We have a cost to produce those products, and it's going to be C of X. C for cost, X is the number of units produced. That's the cost to produce the X units. We'll have a revenue function, which is R of X, and that represents the money that the company makes by selling those things. Okay, the company's profit then is going to be the revenue minus the cost, so R of X minus C of X. The break-even point is the solution to R of X equals C of X. By break-even, what that means is that the company sells enough of their products so that it recovers their cost to make them, but doesn't make enough to make any profit, so they're breaking even on it. All right, so let's try an example. So here it says a bicycle manufacturer spends $120 to build each bike and sells them for $170. The manufacturer also has fixed costs of $150,000 per month. Fixed costs are things that are independent of the number of bikes made, in this case, like the rent or the lease or the insurance or on the building, health insurance for the employees, things like that that are independent of how many bikes are produced. Okay, so we're going to first find the cost function C of X when X bikes are made per month. So C of X is going to be, it says $120 for each bike. So it'll be 120 times X. And then we have to add on to that the fixed costs, which were 150,000. That's going to be the cost to produce X bikes in a month. $120 per bike plus the $150,000 of fixed costs. Next, we want to find the revenue when the X bikes are sold. That's going to be R of X. And the bikes are sold for 170, so that'll be 170X. Okay, we're to find the break-even point, which will be the number of, well, let's get to that. Find the break-even point first. So that will be the solution to where revenue is equal to the cost. Okay, so that will be 170x is equal to 120x plus 150,000. Okay, so there's that. So subtracting the 120x from both sides, that will leave us with 50x as 150,000. So dividing through by 50 should give us 3 followed by 3 zeros. 3,000 looks like. All right, so what is that? What is that? So they can make 3,000 bikes per month. And that 3,000 bikes per month will be enough basically to cover their fixed costs. So they're profiting by on each bike. It's 170 minus 120. So they're profiting by $50 per bike. And so in order to cover that $150,000 of fixed cost per month, they need to sell 3,000 bikes per month in order to cover that $150,000 of fixed costs. In this one, you'll notice that there were kind of two equations, the C of X and R of X, but we really just did this in one variable. For this type of problem, I feel like it's kind of a stretch to make it fit the systems of equations kind of model, so I just probably wouldn't even recommend it. So that takes us to the end of section 4.3 on applications of systems of equations. Finally, let me know if you have any questions, and have a great day.